Picking up on our discussion of format string vulnerabilities, we're now looking at our simple example program in Immunity. So as normal, if I look at my code disassembly in this window and I scroll down, you will see here is my function called vulnerable. You'll see a call to stir in copy and then the call to printf. I can go ahead and set a breakpoint, which I've already done. And I can give this different arguments to determine exactly what I need to get this to work out. So again, remember the calling convention that is being used determines how variables are pushed on the stack. I can use %x to pull variables off of the stack until I get what I want. Then I can determine the value of n, how many characters have been output. I can make sure that that is equal to a value of my choosing. And from there, I can determine what exactly I need to have in my format string to make the right length. That n can then point, for example, to some shell code that I might have uploaded. And I can take that pointer to that shell code and I can substitute it for a return address somewhere on the stack, something that's going to get called. So we're going to walk through that. Let's start out with a pretty simple command string. This one is a working command string that will, in fact, give us the results that we want. But we're going to start fresh here with 24 bytes worth of A, C, D, E, F, and G. We're going to start out with a few bytes and we'll go from there. And we'll put B's back in here. B, 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 B. This is giving me space. So I have 1, 2, 3, 4, 5, 6. Now 7, I'm going to get rid of the G's. So I have 6 sets of 4 characters or 24 bytes, which is enough to inject a little bit of shell code. Then I'm going to pop my characters off of the stack a few times. We'll get rid of these for now in order to get something appropriate. Now, one thing I will do is I'm going to add back in a few values. I'm going to say 0, 0, 0, 0, 1, 6. And I'm going to do that before a few of these strings. I am doing this to make the string that I'm sending to printf be a certain length and hopefully a constant length. Now, when I want to make the output a certain length, these are length specifiers. So here I've specified, please output a length 16 value for X. I'm foreseeing that I'm going to have a few values up to approximately 999,999 at a maximum. And as long as I don't have to change that, that won't change any of these other values. So I have all of those values, then a %n, and then a couple of characters. And we'll see how this works as we go along. So I've set my new arguments, and now I will restart my program. I will run it. I hit my breakpoint, and now I run it again. It is giving me an access violation because I went too far. If I look at the error, it said it tried to go to address 0000. So apparently all of those %x's that I had were just way too much. So I can go back here. Let's take out a few of these. Now, one thing you'll find, this is a very iterative process. You run it, it is going to crash. All right, so we have the value 30302578, which if we look at the ASCII codes, 2 zeros, 25 is the %sign, and 78 is X. So now we haven't gone quite far enough. So let's see how many we need to add. And basically the idea here is that we will keep on adding %x's until we get to the end. %x, 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 %x. All right, so now, once again, we look at EAX, and EAX we're hoping will have our marker of the B's. but instead it has the same thing. So let's go a little bit further. Add to our arguments, %x, 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 %x. We'll add 5 more in here. We will restart. Now I have all zeros. So that tells me I'm somewhere in one of those strings with the zeros that precede the 16s. If we add a few more, we will eventually get to the point of seeing our B's appear in our EAX register. Run it again. And sure enough, we're getting very close now. Notice what we have here. We have 6262, which is the ASCII value for BB. So we are just 1 byte off. If I want to get that extra byte, let's try adding 1 more X and see where that gets us. Okay, restart, run it again. Oh, too far. We've gone past it. What can we do to fix that? I'll go to my arguments here again. I'm going to take out the %x. And you might say, but I was so close. How can I fix this? Well, there is a way to fix this. I'm just going to add a character of P for Phil. I'll restart, run our program. Now we have 626262. So we are now correctly pointing to our string. You might wonder about the zeros at the beginning here and why only 3 B's. And it turns out that the address that we're likely going to try to use for this exploit starts with 2 zeros, which normally is an issue. If you look at buffer overflows, 00 is a null character. So far, we've managed to control the value that's stored in EAX. If I look at my code here on this line, notice that what is happening is I'm copying the value currently stored in ECX into EAX. We'll take a brief break, and then we will talk about how we can fix up ECX to be the value that we want.